Hi, welcome to our channel. Today, we are diving into how Azure Function integrates seamlessly with Azure Database for MySQL, unlocking the power of serverless, event-driven applications with minimal code and operational overhead. Let's start with a real-world scenario. Imagine you need to automatically process incoming orders without any manual effort. Azure Functions combined with MySQL Trigger allows you to do exactly that, handling large volumes of updates, reacting instantly to changes, and streamlining your operations in real time. And the best part? By going serverless, you are not only building scalable solutions, but also cutting down infrastructure and maintenance costs significantly. Azure Functions is a serverless compute service that allows you to build robust applications using less code and infrastructure. It is ideal for event-driven scenarios like processing database changes, triggering alerts, or transforming data on the fly. Recognizing the need for seamless database integration, Microsoft introduced Azure Database for MySQL bindings, starting with input binding. Let the function read the data from MySQL, process it, and drive downstream logic. Next came output bindings, allowing your function to write back to MySQL, whether inserting, updating, or deleting your records. Now, we are excited to introduce you MySQL Trigger, a game-changing feature that empowers your function to react instantly when data changes in your database. No polling, no delays, just pure reactive automation. Let's walk through a simple change data capture scenario. Say that you place an order in your MySQL table. As soon as the change is committed, the MySQL trigger detects it. Azure Function picks it up and forwards the data to Azure Event Hubs. From there, the possibilities are endless. We can store it in Azure Blob Storage for archiving purpose or feed into the Power BI for real-time dashboards. Even trigger further processing or alerts using Data Activator Fabric is possible. Let's start by creating our MySQL database in the Azure portal. In the Azure portal, click on Create a Resource, and then search for Azure Database for MySQL Flexible Server. Select it from the list and click Advanced Create. To begin, fill in the basic details required to create your MySQL Flexible Server. Start by selecting your active subscription. Then choose a resource group. Either create a new one or pick an existing group. For the server name, enter a unique identifier, such as e-commerce DB server, and choose the region closest to your location for optimal performance. Next, select the workload type, either development or small medium-sized or business-critical scenarios, depending on your intended usage. Under authentication methods, opt for MySQL authentication only, and set your admin username and password accordingly. In the networking selection, be sure to enable public access if you plan to connect from local tools like MySQL Workbench or Visual Studio Code. Once all fields are completed, click Review plus Create and then hit Create to deploy your MySQL server. Now that your MySQL server up and running, it is time to create the orders table. You can easily do this using the MySQL extension within the Visual Studio Code. Navigate to your SQL Server resource. Once you are logged in, you can run SQL commands directly in the editor. To create a database and the orders table, simply paste and execute the following SQL script. To let Azure Functions detect changes in this table, we will need to enable change tracking. This is done by adding a special system column or configuring a change tracking for the specific table, depending on the approach. Next, we switch to the Azure portal and create a new Azure Function app. In the Azure portal, start by clicking Create a Resource. Then search for and select Function App. On the hosting plan screen, choose Consumption and click Select to confirm. These plans ensure automatic scaling and cost efficiency as you only pay for the resource used during the execution. Next, proceed to the Basics tab. Select your subscription, then choose an existing resource group or create a new one. Enter a globally unique function app name, then select your runtime such as C# and an appropriate region closest to your users. For the runtime stack, choose the language your function will be built in, for example .NET, then select the version such as .NET 8, select isolated worker model, and finally, once all fields are completed, click Review plus Create to continue with the deployment. Next, we switch to the Visual Studio Code and create a new Azure Function project. In Visual Studio Code, press to open the command palette and then search for and select Azure Functions, Create Function Project. You will be prompted to choose a folder where your Azure Functions project will be created. Select an empty folder or create a new one for this purpose. After that, choose your preferred programming language. In our case, select the .NET 8, isolated. Next, choose the type of trigger for your function. For example, a timer or HTTP trigger, depending on your use case. Once selected, provide a name for your function, then press Enter to confirm. When asked about access rights, select Anonymous to allow function to trigger without authentication. Finally, choose how you would like the project to open. Here, we'll go with Open a New Window to keep things organized. You can use samples for the Azure Database for MySQL trigger are available in the GitHub repository. I'll recommend to start from these resources. First, let's insert a test order into the orders table. This will give us a target row to update. Next, we check the current state of this row, including price and the last known price, which is used by the Azure function to detect price changes. Now, we'll simulate a real update. Let's increase the price by 50. This will modify the timestamp column and trigger our Azure function. Let's see if the function works or not. Let's check if it logs something to the console in the Azure portal or not. Great, our function is invoked successfully. Now, it should have inserted a new record into the order price change log table, showing the old and the new prices. Our function listens to the orders table in MySQL. When the price field of a row changes, it logs the change a separate table called Order Price Change Log. It uses the Azure MySQL trigger and built using the .NET Isolated Worker model. Here is the core of our Azure function. This tells Azure that trigger this function whenever the orders table changes, using the connection string named MySQL connection string. The changes list gives us the updated rows. This block checks whether the row is null and whether the price has actually changed. We use the last known price column in the table to track what the price used to be. This logs the price change so we can see it in application insights or the log system. Next, we insert a new record into our order price change log table to record the change. This uses to execute the SQL insert and logs the old and new price values. Finally, we update the last known price field in the row so that the feature changes can be detected correctly. Let's run a quick test. We update the price of a specific order like this. This change updates the timestamp column which Azure is watching. The function runs, logs the price change, and updates the last known price. Let's check the order price change log table to confirm the function executed as expected. And that's how you build a real-time database-driven trigger using Azure Functions and MySQL. Fully serverless, minimal code, and lightning fast. Let's continue to the video with natural transition into how Azure Functions can send messages into Azure Event Hubs, enabling real-time analytics, dashboards, or downstream automation. In Microsoft Fabric, we connect to the same event hub from the event stream and then route that data to a KQL database or a lakehouse for future analytics. From there, you can build real-time alerts, visualize price trends in Power BI, or trigger downstream logic with the data activator. And that brings us to the end of this tutorial. Today, we build a fully serverless real-time pipeline. We listen to the changes in a MySQL orders table using Azure Functions, detected the price changes and logged to the change log table, then stream those changes to the Microsoft Fabric using Event Hub for real-time analytics. Whether you are tracking order updates, syncing the data, or triggering alerts, this pattern is powerful, scalable, and fully cloud native. If you found this video, please like this video and subscribe to the channel for more tutorials on Azure, Fabric, and real-time data pipelines. Thanks for watching and see you in the next video.